All right, algebra, let's start a new chapter. We are in chapter 5, section 1, and we need to warm up. Now, as I've said, warm-ups are very important because they remind us of things we've already learned in the past that we need to know before we start the new section. So, let's go ahead and get started. If I say y varies directly with x, that means whatever is y is something with x. Well, let's do this. So if y varies directly with x, if y equals 36 when x equals 8, find y when x equals 5. Right? For these, I just multiply down, excuse me, and I need my calculator. 36 times 5, if I multiply down, I get 180 equals 8y. Then I divide both sides by 8, and I can say that y is 22.5. Okay, these are just ratios. If you travel at a constant speed, the distance you travel varies directly with time. So distance varies directly with time. If you travel 182 miles in 3.5 hours, how far will you travel at the same constant speed in 5 hours? Again, I'm going to cross multiply. 182 times 5 is 910 equals 3.5d. Divide both sides by 3.5 and I get d equals 260 miles. All right, so let's look at a key concept for this chapter. Two variables x and y show inverse variation. We just went through two examples where it's direct. Now it's inverse. If they are related as follows. We have y equals a over x. A cannot be 0. The constant a is the constant of variation. And y is said to vary inversely with x. See how y is at ground level and x is in the basement? That is our inverse variation. Tell whether x and y show direct variation, inverse variation, or neither. Okay, these right here are like the, like what we just learned. Okay, if I solve for y, I have to divide both sides by x, and I get y equals 7 over x. So that is inverse, where a equals 7. Okay, here I don't have any multiplication going at all. So there I have neither. And here I have y over 4 equals x. Okay, if I went ahead and cross multiplied, I get y equals 4x, which you see right here, and that is in fact the direct variation that we have just completed. Okay, I can also say that these are both ground level or numerator, therefore direct. These are numerator and denominator, or ground floor and basement, therefore inverse. Okay, you have to memorize this. There's no way for you to get it unless you just memorize that when I have ground floor and basement, it's inverse. When I have ground floor and ground floor, it's direct. When I don't have any multiplication going on at all, it's neither. Okay? Trying to get rid of all this so you can see. All right, good job. All right, the two variables x and y vary inversely. So we have y equals a over x, and y equals 7 when x equals 4. Write an equation that relates x and y, then find the value when x equals 2. So here's my equation when x and y are given. So I'm going to put 7 over 1 and cross multiply. 28 equals 1a. I never have to divide by 1, but a equals 28. There's my solve for a. Your inverse variation equation, so the equation is y equals 28 over x. And then when x equals negative 2, y equals negative 14. Okay, so we answered both parts of the problem. Let's put that into a word problem. I have the number of songs that can be stored on an MP3 player varies inversely with the average size of song. So the number of songs that can be stored in an MP3 player varies inversely with the average size of the song. So let's do this. Number of songs varies inversely with the size of songs. So the number of songs is N and the size of songs is S. A certain MP3 player can store 2,500 songs when the average size of the song is 4 megabytes. Multiply. I have A equals 10,000. Okay, write a model that gives the number of N songs that will fit on an MP3 player as a function of the average song size. So we have N equals 10,000 over S, because we just solved it up there, right? Cool. Next part says, make a table showing the number of songs that will fit on the MP3 player if the average size of a song is 2 megs, 2.5, 3, and 5 megabytes, as shown below. What happens to the number of songs as the average song size increases? Well, it's inverse. Therefore, as the average song size increases, the number of songs should decrease. So if I say the average size of songs in megabytes and the number of songs, and they said 2 megabytes, 2.5, 3, and 5. I'm going to use my model, which was N equals 10,000 over S. S is given. Divide by 2, I have 5,000 songs. Divide by 2.5, 4,000 songs. Divide by 3, 3,333 songs. I have to round that because that was a decimal. I rounded to the nearest whole song. And then 2,000 songs. Cool. So we know as the size increases, the number of songs decreases. All right, let's practice. Tell whether X and Y show a direct variation, inverse variation, or neither. Here I've got both things on ground floors, nothing in the denominator, so I am direct. Here, if I solved for 1, I'd have the other one in the denominator, so ground floor and denominator, therefore I am, can't spell, inverse. Here I have nothing multiplying, it's a linear equation, so it is neither. Two variables x and y vary inversely. Use the given values to write an equation relating x and y. Then find y when x equals 2. So these are inversely. I've got y equals a over x. Plug in what I know. 3 equals a over 4. Go ahead and cross multiply. A equals 12. So my equation would be 12 over x. Then find y when x equals 2. Y equals 6. The variables x and y vary inversely. Use the given values to write an equation relating x and y. Find y when x equals 2. Okay, same instructions. I have y equals a over x. Negative 1 equals a over 8. Okay, cross multiply. Negative 8 equals a. So my equation is negative 8 over x. And then find y when x equals 2. So y equals 4. Good job. All right, last example. Same instructions. Y equals a over x. 12 equals a over 0.5. So cross multiply. I have 6 equals a. So my equation is y equals 6 over x. And then find y when x equals 2. Y equals 3. Cool. Nice job. Okay, last practice. What if, in example 3, What is the model for MP3 players if it stores 3,000 songs when the average song size is 5 megabytes? So here we had N equals A over S. 3,000 songs is A over 5 megabytes. 15,000 is A. So my model would be 15,000 over X. Y equals 15,000 over X. Not X, sorry. S. And not Y. Haha. You thought you were finding all my mistakes. There we go. Okay, next type. Checking for inverse variation. The general equation y equals a over x for inverse variation can be rewritten to say xy equals a, because I can do y equals a over x, cross multiply, xy equals 1a, oh gosh, a, we don't need to write 1, so we can say xy equals a. This tells you that a set of data pairs xy shows inverse variation if the products xy are constant or approximately constant. Moving to the example. The table compares the area A in square millimeters of a computer chip with the number C of chips that can be obtained from a silicone wafer. Write a model that gives C as a function of A. Okay, so we see all of our data there. And then we're going to predict the number of chips per wafer when the area of a chip is 81 square millimeters. So we're going to take this data and write a model and then predict, okay? So first, we are going to calculate the product AC for each data pair in the table, okay? Remember we said XY equals A, so we're actually going to multiply A times C for each one. So as I multiply each one of these, I'm going to push pause and finish multiplying because these are, you don't need to wait for me to multiply two numbers. So I'm going to finish multiplying these. You guys can do the same. I'm pushing pause. All right, so we can see that each product right here is approximately 26,000. I know we're estimating here. So the data shows an inverse variation. So we can say that A times C is approximately 26,000, or C equals 26,000 over A. So there would be a good model for the data, right? Sorry, that's an O. Okay, step 2. Make a prediction, the number of chips per wafer for a chip with an area of 81 square millimeters. So we have 26,000 over 81. The number of chips we would get is about 321 chips. What if, in example 4, predict the number of chips per wafer when the area of each chip is 79 square millimeters. So I think we had 26,000. So the number of chips equals that over 79. And we get approximately 329 chips. Okay, a new concept. Joint variation occurs when a quantity varies directly with a product of two or more other quantities. In the equation below, A is a non-zero constant. So here we have Z varies jointly with X and Y, or P varies jointly with Q, R, and S. Okay, these are all on ground floor, all in the numerator, and A is a non-zero constant. So if we look at our first example, the variable Z varies jointly with X and Y with a constant, all right? Also, Z equals negative 75 when X equals 3 and Y equals negative 5. Write an equation that relates X, Y, and Z. So here we have A times negative 15. If I divide both sides by negative 15, I get A equals positive 3. Nope. 1, sorry, that's not 3. Tried to do math in my head and failed, but it's okay. This would be 5, right? So my equation would be z equals 5xy. And then find z when x equals 2 and y equals 6. So 2 times 6 is 12, times 5 I think is 60. Sorry. It is z equals 60. Nice job. All right, now we're going to compare different types of variations. Okay, write an equation for the given relationship. So I've got relationships and equations. Y varies inversely with x. Z varies jointly with x, y, and r. Y varies inversely with the square of x. I'm just writing it as I say it. Okay, no real thought is going into it. Z varies directly with y and inversely with x. Just putting the letters in as I say what to do. X varies jointly with t and r and inversely with s. Perfect. So let's try a few. The variable z varies jointly with x and y. Use the given values to write an equation relating x, y, and z. Then find z when x equals -2 and y equals 5. So z equals a times x and y. Therefore, a equals 7/2. So z equals 7/2 xy. Now we want to find z when x equals -2 and y equals 5. Okay, this right here is -1. 7 times 5 is 35, so -35 would be z. Here we have z equals a times x and y. So I get 24 equals -12 times a. A is -2. Now, what is z when x is -2 and y is 5? Z is +4 times 5 is 20. And same problem. So I have z equals a times x times y. That is a -12. This gives me -3/2, which is -1.5. Now we want to find z. A, x is -2, y is 5. So that right there is -1. That's positive. Z equals 15. Last one like this. I have 56 equals a times -6 times -4. 56 divided by +24 is a fraction. 7/3. So a equals 7/3. Now let's solve for it. A times -2 times 5. I have z is -70/3. Oh, I didn't mean to keep these answers in. That's so funny. Write an equation for the given relationship. So, all right, we've got x varies inversely with y and directly with w. So I can put w up here. Let's write that better. Varies inversely with y and directly with w. I can write it like that, or I can write it like this. right? Doesn't matter. P varies jointly with Q and R and inversely with S. I'm just writing them as I read them. And then the daily homework quiz. Okay, this is just extra practice with your answers. Extra, can't even write. Okay, so you can practice. Nice job. I'm all done. Good work today. Yeah, that's all I got.